Okay, so from Friday, we practiced labeling the sides of a right triangle. If we had any given triangle that is a right triangle, and then we had an angle in it with this symbol. Do you happen to remember what that symbol is called? Okay, so what is this symbol called? Theta. Short E.
What?
Theta. Theta is a Greek letter of the alphabet. You know, just like we have A, B, C, D, E, F. Okay, so the Greek letters are alpha, beta, there's theta. You don't have to write these.
Yeah, they told me that last year.
Gamma. There's gamma. I don't know all of the Greek. I'm not claiming to know the Greek alphabet. I know the ones that get used the most in math, and those are the ones that get used the most.
Miss Hawkins is really smart.
You will. Some of them you've seen in every. Like there's a bumper sticker that says coexist. Have you ever seen that? And the word coexist is made out of symbols. Like the O is a peace symbol.
I've seen like colleges.
The A is this alpha symbol. Theta is not hard. It's B with a tail. Theta I already know. Now gamma is the one that drives me nuts because it's literally it looks like a Y with a hook, but it's gamma. But anyways, okay. On Friday we talked about theta is just a fancy X for a missing angle measure. And on Friday we practiced labeling the hypotenuse, then going to theta, drawing your attention to it, and labeling the last two sides as opposite and adjacent. Remember that? That's very important. That is laying the groundwork for today. Okay. Which brings us to this paper, which I believe is page 68. Oh, it's 69. All right. So this is page 69. Okay. This page is going to lay the groundwork for what trig is. Trig is 3 formulas. The way I've learned how to teach this over the years is instead of trying to teach all 3 formulas at once, I've learned that students do better if I teach you one of them, we practice it, and then once you have that down, then I teach you the other 2, which is the same approach, and people do better. So we're not filling this whole paper in all at once, so we're going to be jumping around, okay? Right here at the top, it says, what is trigonometry? It is the study of right triangles. It's the study of right triangles. So what shape are we going to be looking at this entire unit? Triangles. Right triangles. There are 3 trig functions. Okay? There's 3 of them. I don't want you to highlight just yet, okay? But I'm going to draw your attention and then I'm going to erase what I highlight. There's sine, cosine, and tangent. Now those are the 3 formulas that are involved in trig. We are only going to look at tangent today. I've learned that if you start with tangent and you practice just tangent, then sine and cosine are easier, okay? So I do want you to get a highlighter, and we are going to highlight just tangent for right now. Tomorrow we will highlight the others as we learn them.
That's Holcombe. You better not remove me from your Google Classroom. I need your help.
Your what is it? I think you automatically get removed when you.
Oh no! Don't take me out of something.
But I don't think then. I think when you get put in the other Google Classrooms, it creates issues on your landing. I don't know.
I'm just figuring out the log.
Alright, so we're gonna do just tangent. We're gonna focus on just tangent. What is tangent? Tangent is the ratio of opposite over adjacent. So if you come back to Friday's lesson, the 3 words we used to label triangles was hypotenuse, opposite, or adjacent. The trig function, tangent, involves the opposite and adjacent. Okay? So for instance, if you look over here, it says, this is how you're going to see it. It says tan A equals blank. It says tan B equals blank. When you have trig functions, where can we write this? Let's write it, we'll write it right here. When you have trig functions, it's always the trig you're using, whether it's sine, cosine, or tangent, the angle equals the fraction bar, and it's going to be a side over a side. This is called your trig function. So it's like a formula. So every time I say set up your trig function, that's what I'm looking for. And today we are only doing tangent. So every time you set it up, it'll be tan, angle measure, equals fraction bar, and then in the fraction bar goes the 2 sides. Now how many sides does a triangle have? 3. How do you know what 2 sides to use? We are only learning what today? Tangent, which uses what 2 sides? Opposite and adjacent every time. That's all we're doing today. Alright, so if I was setting up my trig function for tangent of angle A, look over here at this bullet point. So tan angle A equals, there's my fraction bar. I'd have to come over here at this picture and I'd have to ask myself, from angle A, what is opposite of angle A? What side is opposite of angle A? Side. What side is opposite would mean it's the side farthest away, not touching it. Do you see that? Alright, so what side is opposite? Little a. And then what side is adjacent to angle A? Come in here and draw your arrow to the hypotenuse so that you don't accidentally call it the wrong thing.
So it'd be B, right?
Very good. So let me ask the question again. When looking at this picture, focusing your attention from angle A, we've already said that little a is opposite. What would be adjacent? Little b. And notice that's because little c is the hypotenuse. So it'd be A over B. Now we're going to set the formula up for tangent of angle B. We're going to do this one right here. Okay, so now focus your attention. I'm going to erase that arc. Focus your attention here. What is opposite angle B? Little b. Opposite meaning the side all the way across, not touching. Little b. And then what is adjacent to angle B? Huh? Little a. Adjacent means touching. Do you see that? But it's not the hypotenuse. Alright. So there's our 2 formulas. Now, if you don't get it yet, don't worry. We haven't actually even done a practice problem. Right now I'm just showing you how to read the triangle. So come right here. We are only focusing on tangent. Tangent, the tangent formula, it should say right here angle measure. I don't like that. Let's put an angle there. Tangent of the angle equals opposite over adjacent. Tangent of an angle equals opposite over adjacent. All right, we're going to start simple with just numbers, no x's, okay? Give each trig ratio a fraction in simplest form. Okay, so our answers need to be fractions, which is why you need your graphing calculator, or your calculator. All right, let's look at number 1. We are only going to answer the tangent questions. Don't use your highlighter. Let me highlight mine. We're going to answer just the tangent questions. Okay. Go to your triangle, draw your arrow from the right angle to the side opposite. That is the what every time? Hypotenuse. You need to label that every time so that you don't accidentally call it something else. Now the other two sides, they get different labels depending on what angle you're focused on. Okay? Alright, so we're going to write the fraction for tan of A. Normally it's called, though, the trig ratio. We're going to write the trig ratio for tan A. Tan means opposite over adjacent. A means stand your attention from angle A. So I'm going to come right here and I'm going to draw this. So from angle A, what is the side opposite? Imagine yourself standing in that angle A and like looking at the triangle. 5 is opposite. And then what's adjacent?
12.
Very good.
I actually paid attention.
Do y'all see that? Like that's it. That's the answer. That's all we do. Because there's no x. Like I said, we're starting simple. Let's just make sure you can set the fraction up right before we start diving into find x. Now, 5 over 12 does not reduce, so you would leave it at that. All right, I want y'all to find tan C. So this time your attention is over here. And you're setting up the trig ratio for tan C. Well, the formula for tan is what? Opposite over adjacent. So from angle C, identify the side that's opposite, then identify the side that's adjacent, and tell me what fraction you get. Yep. What do you notice?
Opposite.
They're the opposite fractions, right? That's because they're from the same triangle. That's a pattern. That always happens. As long as they're from the same triangle. If you find tan of one angle, it will be the opposite fraction as tan of the other angle. Do you notice a certain angle we've yet to use? That right angle, we've yet to use that. And that's like a, what is it? Like a watch out. Let's say watch out. Never use the 90-degree angle. You never use the 90-degree angle in a trig ratio. The 90-degree angle is in the triangle to let you identify the hypotenuse. And that's the only purpose of it. You only use trig ratios of the acute angles, which means the two non-right angles. Right? All right, let's try example 2. Example 2, we are doing tan W and tan X. I want you to try it. So it's opposite over adjacent. Draw your arrow from the right angle to the hypotenuse. Now these fractions will reduce, so when you do set it up, go to your calculator, type it in, and then to get the reduced answer, you're going to hit Math Frac. Okay, so what was the original fraction for tan W? So from W, what's opposite? 12. What's adjacent? Okay, so the original is 12 over 9, and what does that reduce to? 4 over 3. Very good. So I do need you to start practicing reducing your fractions. Let's make a note. Calc. You're going to enter, so for example, we said 12 divide 9, and then you hit Math Frac, and it will give you the reduced answer. So make sure you remember Math Frac. Okay, if tan W is 4 over 3, then what is tan X? 9 over 12, which reduces to 3 over 4. Very good. All right, let's do number 3, tan L, tan M. So we're going to go to our picture, draw an arrow from the right angle to the hypotenuse, label it. What do you notice? We don't know the length of side KM. Did we learn a technique for finding a missing side of a right triangle?
Yeah, the Pythagorean.
The good old Pythagoras, right? So we have a little bit of work to do before we can find the ratio. Let's come over here and let's set up our Pythagorean theorem. This is one of the legs, so you could call it A or B, doesn't matter. I'm going to call it A. So if I have A squared plus 16 squared equals 34 squared, and then now you need to solve for that missing side. Please do that right now. You should get a pretty number.
Yes, can I have another tissue, please?
Yeah. There you go.
I get 2.
That's fine. All right, what did you find as the missing link?
30.
Yes, you should have, let's see, 16 squared, is that 256? Okay, and then what's 34 squared? And so then you subtract the 256 and you get 900. And then you square root both sides. And we get A is 30. Did y'all get that? So this is 30. Now we can set up our trig ratio. So come over here, tan L, tan M, and set up your trig ratio. I know, right? We are going to have a quiz on it tomorrow. It was supposed to be Friday, Too many people out Friday, and I hate to give it on a month. Like I don't know. Jeez.
If you didn't fake sickness, we'd have that.
Yeah.
Is there gonna be an individual quiz for each of these three?
Yes.
So the quiz, you're talking about all three? Are you saying all three?
Yeah, like is
They're
there gonna
gonna
be
be
one for
together,
labeling sides,
or
one for
separate?
the triples?
Wait, no, I think she's asking a different question.
Since you're only teaching them like one at a time. I mean,
So the quiz would cover all three.
So we're gonna learn the other two tomorrow?
Well, we might learn them at the end of class today. I don't know. Depends.
I wonder how behind I'm gonna be over there.
All right, what'd you get for the trig ratio of tan L? So L is over here, opposite of L, 30, adjacent to L, 16, and then you should have done math frac. Did you get 15 over 8? All right, tan M. There it is. And then that would be 8 over 15. So what do you think about labeling a triangle? Yes? Like labeling? Okay. What do you think about using Pythagorean theorem to find a missing side? What do you think about writing the trig ratio for tangent? Setting it up.
Get off your thumbs.
Oh, I'm a kid. Go to, I guess he's found my email address. It's in third grade and he's emailed me. That's funny.
How is it like you're working?
Well, yeah, I work in the same county. He's in
Oh.
third grade. He has an email address because he's a student in the county. Okay.
I used to share Google Docs with my mom. And type them.
Oh, like a running chat?
Yeah.
I got in trouble for that in middle school.
Yeah.
I
When
was
she
smart
when she
enough.
took my phone away, I was like, "Hey, mom."
Oh my word.
I was
Y'all
smart
are
enough.
sneaky. Okay, go to the back. Go to the back. All right. So we've covered the level 1 stuff, okay? Now we're into level 2. But the beauty of it is nothing changes. It's still tangent, angle measure equals fraction bar. You fill the fraction in using opposite over adjacent. The new part here is now you can see what's the point of trig. The trig is when you have a triangle. Look, for instance, at number 4. Look at number 4. There is an x right here that I need to know. Well, can I use the Pythagorean theorem?
Yep. Nope.
I cannot use the Pythagorean theorem in number 4. Can anyone explain why? There's not enough info. For Pythagorean theorem, we need 2 sides to start with. So enter trig. Trig will let you find the value of missing sides of a right triangle when you don't have all the info that you could use for Pythagorean theorem. All right. We are only covering today, or as of right now, tangent. So if you recall, we're going to copy this from the front so that we don't have to flip over. Your trig function for right now, since we're using tangent, will be tangent, angle measure, equals fraction bar, and with tangent, it's opposite over adjacent. So if I say, set your trig function up, that is exactly what you're doing. That's a formula for you. It's going to be tan angle equals fraction bar opposite over adjacent. And what angle did we say never goes right here? Which one did we say we never use? The right angle. So please don't ever set it up tan 90. It's never something 90, okay? There is something we have to make sure is in order in your calculator. I would love for you to highlight this right here. This whole box right here. Please highlight that. You will notice it says make sure your calculator is in degree mode. Your calculator has multiple modes, but in terms of like measures of angles, there's two forms of measurement. There's what's called degrees, and then there's what's called radians. If you will look at the top of your screen, do you see the word degree or do you see the word radian?
Radian.
Okay, so let me show you how to change it. You would do, let's go right here, calc. You're going to hit the mode button. You're going to arrow down until you hit degrees, and you're going to hit enter. So mode, arrow down to the word degrees, make sure it's highlighted, arrow over to it, hit enter to highlight it, and then you can hit clear to get out of the menu.
Oh yeah, I'm on degree.
Now your calculator should be in degree mode. Now, I have good news and bad news. The bad news is if you forget to change your calculator to degree mode, when we start finding X or a missing angle, you will get the wrong answer because your calculator is in the wrong mode. But the good news is the answer will be so wrong it will not look right. Like something will be off. It won't make sense. You know what I mean? So there will be some type of red flag to indicate, hey, this is so wrong. You should recognize, oh, I forgot to change modes. Okay? Which I would remind you to change as well. All right. Now let's actually dive into solving. Can you find an example that gives me the opposite and adjacent of the triangle? I need an example of just the opposite and adjacent. So which one would that be? In terms of the triangle, like if you labeled the triangle, this time from the angle given, like number 4. Let's look at number 4. What is the 19?
Oh, it's the
19 is the hypotenuse. Did we use the hypotenuse in tangent?
Yeah. Wait. No.
Did we use the hypotenuse in tangent? No. So that is not a tangent function. Let's go to number 5. Draw an arrow from the right angle to the side opposite of it, which is the hypotenuse. Do you notice how it's blank? Do you notice it's blank? Meaning there's not a variable or a number? Every time the hypotenuse is blank, it's a tangent problem. Okay? Every time the hypotenuse is completely blank, it's a tangent problem. So that means this is going to be a tangent problem. So here we go. Here's the new part. Ready? All right. I've identified it's a tangent problem. I'm going to the angle that they give me, and I'm going to draw an arc to direct my attention there. Now I need to label opposite and adjacent. What is opposite of 41?
X.
Okay. What's adjacent?
32.
Notice I labeled with an O and an A, so that when I go to set it up, I'm going to just plug it into the formula. Okay, what's the formula? Write up your trig function. Tangent, angle measure, equals fraction bar. Opposite over adjacent. So watch how I do this. Tangent, what's the angle I emphasized? 41. Equals fraction bar. What's opposite? What's adjacent? Does everyone see how I got that equation?
Yes.
That's my trig function. You have just done the hardest part, which is just setting it up. Now what we need to do is actually get x by itself. Okay? And there's a pattern here. I'll show you the pattern once we hit the second example. X is right here. I need it by itself. What's in the way? What's in the way of x being by itself? 32. How's it attached to the x? Huh? Division. So what's the opposite? Multiply. I want you to draw, it's called an elbow arrow. I coined that phrase. And the reason why, I don't want you to just draw that because that looks weird. I want you to draw this to say, okay, I'm going to multiply that right there in the front. It's going to be 32, 10, 41 equals x. So it multiplies to the other side of the equation. I want you to draw the elbow arrow. And I say elbow arrow because I want it to have that little, like, whoop, coming over here. It's going to go to the front. Now, is x by itself? Nope. Which means we can type this in our calculator, get our answer, and move on. So, go to your calculator.
Mine has to update.
I'm in red. Hold on, let me change mine to the green. Alright, we're going to type in exactly how we see it. I see 32. Look right here, there's 10. 41. And then because it naturally opened the parentheses, you don't have to close it, but it bothers me, so I'm going to close it. And there's the angle, or there's the missing side length. Let's round to the nearest tenth. So, real quick crash course in rounding. If we're going to the nearest tenth, then we're checking the number next to it. And we ignore everything after that. A lot of people start domino rounding, like they check you know what I mean? Like, if you're going to the tenth, you check the 100th. That's it. The 100th is a 1, which means it's not enough to bump the 10th up. So it'd be 27.8 is my answer. And that is the length of the missing side. All right. Look at number 6. Is it a tangent problem? 6. How do I distinguish when it is or is not? Draw an arrow from the right angle to the hypotenuse. If the hypotenuse is blank, it's a tangent problem. So is number 6 tangent? No, so we're going to skip it for now. What about 7?
Yes.
Yes. 7 is tangent. I'm going to draw an arrow to the hypotenuse. I'm going to write the word blank. So now I know, okay, this is tangent. I'm going to put an arc on the angle I'm emphasizing. And then I'm going to label the opposite and the adjacent based on that arc. So what's opposite? Good. What's adjacent? Very good. Then I'm going to set up my trig ratio, my trig function. Tangent, angle equals opposite over adjacent. Did you get it? All right, now we have to solve. Look at where x is. X is in the top. What's attached? An 8. How? How's it attached? It's attached by division, so I'm going to move it by multiplication. I'm going to draw my little elbow arrow right there to show that it's going to the front. Let me show you why the elbow arrow is helpful. Don't write this. Red means wrong. I have seen people set it up correctly And then they know, okay, this has got to multiply over here. What do you think they end up doing?
The long and
They end up multiplying that number with the angle measure, and that is a big no-no. That angle measure is degrees. This number is the length of the side. That's apples and oranges. So that's why I like to do the elbow arrow, so that people will remember, okay, it does multiply, but it comes over here to the front. It doesn't actually change that 55, okay? All right, then you go to your graphing calculator, and you type it in. What'd you get to the nearest 10th? Very good. What do you think? Let's find the next question that involves tan. Can you tell me the next one? Yes. How do I know? Yes, you're looking for that hypotenuse to be blank. So number 10, draw the arrow. That's definitely blank. Emphasize your angle. Label your opposite and adjacent. All right, let's set it up. Now this one ends up, you set it up the same, it's just it looks a little different this time. All right, so tell me what the trig function is. Tell me what to write. If I was a new kid and I had no clue what I was doing and you were helping me too much, what would you tell me to write? Bam. What's different here than the last two that we've done?
25's on top.
Okay, there's two scenarios every time. This is another thing that I love about trig is it can't get more, like there's only one level of difficulty, right? There are two scenarios on where your x could be. Your x could be the opposite or your x could be the adjacent. And when you set up your trig function, the way that it looks different is it's either in the top of the fraction or it's in the bottom of the fraction. The beautiful thing, though, is you still start to solve it the same way as you do regardless of where it is. Whatever is in the bottom of the fraction has got to go, okay? It's got to come over to the other side by multiplication. So I'm going to draw my elbow arrow, and I'm going to write that, okay, so that x is crossing over. Now I have no more fraction. But then you ask yourself, am I done? Now, in the previous problems, we were done. We were ready to go to the calculator because x was now by itself. In this problem, we are not done. What needs to move? What needs to go to the other side?
Tan 72.
Tan 72. I need you to think of that. Do y'all remember those blocks, wooden blocks that kids used to play with? And they would just stack them and create castles or towers. No, just blocks in general.
Yeah.
It was like a wooden block. I want you to visualize tan 72 as like a block. Because I don't want you to break apart the tan and the set, like I want them together. I need to move that to the other side using the opposite. What's the opposite of how it's attached? Division. So here's, if you will show your work, you will know what to type in. If you don't show your work, it's more challenging on what do you type in the calculator. I can see that tan 72 has got to go. It's going to move by division, so I'm going to come over here and write divide tan 72. And that's exactly what we type in the calculator. We're going to type 25 divide tan 72. Oops. Hold on. Alright. This calculator is too big.
You weren't on that guy.
Alright, I'm trying not to cover the whole thing. Okay, we're typing in 25 divide tan 72. And then we get 8.1. So x equals 8.1. Alright, here's the beautiful part about trig. You paying attention? Let's take your highlighter. Y'all know how highlighted notes in a strategic way is very helpful. I want you to highlight the edge here and then the edge here. And I'm going to tell you what to write. Highlight those edges. Now, here's what we're going to write. We're going to write that this is scenario 1. SCENARIO, and this is scenario 2. Meaning, you have a frame of reference for the 2 different possible scenarios every time. Either x is in the top of the fraction or x is in the bottom of the fraction.